Hello everyone, I'm Shaurya and this will be the solution video of problem 6, Raccoon fished on a trash lane of TCP Open Contest 1. Okay, so let's dive into the problem. The problem is Raccoon fished on trash lane. Okay, deep in outskirts of Garbage Valley, a gang of hopelessly lazy raccoons has taken up residence along a long, infinite lane. These raccoons are so lazy that they refuse to move even a single inch. If food doesn't come to them, they'd rather starve or at least complain about it. The only source of food, trash cans, strategically placed along the lane. But the raccoon won't go to the trash must come to them. Okay, so the raccoons won't move, the trash must come. All right. Whenever a trash can overflows, the garbage spreads outwards in circular zone with a radius r, covering all nearby raccoons who are lucky enough to be caught in the trash wave. If a raccoon is uh, within the radius of at least one overflowing trash can, it gets fished without lifting a paw. Okay, your mission is to find the smallest radius r that ensures every raccoon has access to at least one trash can garbage, because heaven forbid they actually move to find food themselves. All right, so in the problem we are given an integer n, that is the number of raccoons, then an integer m, that is the number of trash cans, then we are given a sorted list of n integers, the x coordinates of raccoons, and then the sorted list of m integers, the x coordinates of trash cans. All right, the constraints on n and m is 1e5, and the constraint of the coordinate is from minus 1e9 to plus 1e9. All right, in the output we have to print a single integer, that is the minimum radius needed so that every raccoon can have basically food, right? So this is the input. So let's say the input, we have given 5 raccoons and 5 trash cans. The coordinate of raccoons are, so let me just draw it on a number line. So this is a number line. The coordinate of raccoons are minus 5, minus 2, 1. So it is minus 5, minus 2, 1, 4 and 10. 4 and 10. Okay. And the coordinate of trash can is minus 3, 0, 3, 8, 12. Okay. So minus 3 here, then 0, 3, then 0 here, 3 here, 8 and 12. 8 here and 12 here, right? So now see, for this raccoon, if this trash can spreads to a radius of 2, this raccoon can get this trash, right? So one thing is clear, that a raccoon must try ki it gets the nearest trash from the nearest trash can, right? So for this the radius is 2. For this, from here it is 1, from here it is 2. For this, from here it is 1, from here it is 2. For this, from here it is 1, from here it is 4. For this, from here it is 2, and from here also it is 2. So we can see, if we just take 2 as the minimum radius, minimum radii through to which every trash should spread. So this trash will spread to this one and this one, so these two will be covered. All right, and from this trash can, this will also be covered, this raccoon will also be covered. From this trash can, this raccoon will be covered. From this trash can, this will be covered and this will be covered. Wait, just let me mark it. From this trash can, see, these two are covered already, right? This one and this one already covered from this trash can. From this trash can, these two are covered again, this one is covered again, and this one is also now covered. Sorry, we have to, these blue ones are the trash cans, right? From this trash can, these two are covered, the -2 raccoon and the 1 raccoon. From this trash can, these two are covered again. From this trash can, this will be covered, right? This will be covered, and from this trash can again, this will be again covered. So we can see, if we take radii as 2, then every raccoon can get a feed. If we take the radii as 1, many raccoons will not be able to feed. For example, this one, this raccoon needs at least someone from distance 2, because the nearest trash can is at a distance 2, right? So now, how do we approach this problem? So guys, like, let's see, let's assume our answer is x. Okay, our answer to the problem is x. X is what? X is the minimum radius through which each trash can should spread its trash so that each raccoon can get a feast, right? So x is nothing but the minimum radius through which each trash can should spread its trash so that each raccoon can get a feast. All right, so what does it means? Like, let's say if there is a raccoon, only a single raccoon here, R, and only a single trash can here, T, and this is their distance x that I'm talking about. So if this trash can, if it let's say spreads the trash of radius less than x, then what do you think? Will this raccoon be able to feed it? No, right? But what about if it spreads the trash of radius greater than equal to x? Of radius greater than equal to x. Suppose this or this. Then this raccoon will be able to feed, right? So we can see there is a monotonic nature. We can come to a conclusion. We can come to a conclusion that there is a monotonic nature of our answer. Right? There is a monotonic nature. For example, if the trash can for x, if there is a point till, if radius is like this, then the raccoon will not be able to feed on the trash can. But after a point, when it reaches x, after that, if we increase the radius again and again, then it will be able to feed, right? So for here it is false, 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 false. That means the raccoons are not able to feed. And after this point x, all the raccoons will be able to feed, right? So there is a monotonic nature of our answer. So whenever this happens, what we apply? We apply nothing but binary search on answer, right? If we can see there is a monotonic nature, then we should apply the binary search on answer. So we can apply the binary search here. So if there is an answer, we will move our pointer here, and if there is not an answer, we will again move the pointer here, right? So let's see. So we understood, like, there is a binary search involved. There is a binary search on answer involved, right? So now the problem is, how do we determine whether the x is sufficient or not, whether the x is sufficient or not, x is sufficient or not, right? So for that we need a predicate function. For that we need a predicate function or a predicate logic. Okay, we need a predicate function. So how do we create a predicate function? Basically, let's see the code first, right? Let me show you the code. So here we are given the input n, we are given the input n, m, the vector of Raccoon, the vector of trash cans, right? So here I'm taking nothing but n and m as input, then I'm defining my vector a and b and taking the input as a and b. This is nothing but my template for taking the input of vector. In fact, you can write the simple code of taking the input. Then what I'm doing, I'm taking two pointer as low and high. And why here high is 2e9, because you can see like the constraints were given as -1e9 to 1e9. So what if there's a Raccoon placed at -1e9 and there's a trash can placed at positive 1e9? There's a Raccoon, there's a trash can placed at positive 1e9. Okay, so this is a Raccoon, this is a trash. So it will take a radius of 2e9. So our maximum answer could be 2e9. But there is an input I want to give you here. Like this is the key takeaway from this problem, that you can take 1e18 also as the upper bound. Why? I would suggest always use lower bound as 0 or 1 or upper bound as 1e18. Now you will ask, sir, but it will increase the count, right? But again, it's a logarithmic function. So log 1e18 will be 60 and log 2e9 will be somewhere around, let's say, 30. So there's not a major difference here, right? There's only a factor of 2 involved. So that is a constant factor. So you can always take the upper bound as 1e18 and you will be good to go. So you don't even need to consider what should we take the value of low and what should we take the value of high. You can always take low as 0 or 1 and always take high as the upper bound, that is 1e18, and it will always give you a correct answer. So now here I've explained why I've taken high as 2e9. Then I have initialized my answer as -1. Then it is a simple while loop. I'm calculating the mid. Here mid is nothing but mid is low plus high by 2. Okay, this is a way of writing mid as, see, let me explain why I've written mid as like this. See, because low plus high by 2, right? This can also be written as, low plus high minus low by 2. Okay, expand this one. 2 into low plus high minus low divided by 2. This will be again low plus high by 2. Okay, what's the use of doing it like this? Sometimes because as I've told, we are taking high as 1e18, so there might be an integer overflow. What if low is also 1e18 and high is also 1e18? So there will be an integer overflow. In order to escape that integer overflow or long overflow, we use this technique. Okay, and here I am shifting the bits as right shift 1, that is nothing but divide by 2. Okay, let me just clear it once. So now I'm calling my predicate function. If it returns true, that means we are able to feed the raccoon, right? If it returns true, that means we are able to feed the raccoon. And then we will move our pointer over here. We want to find the minimum value, right? So if it has returned a true, that means we were able to feed the raccoon. Now we want to find a more minimum answer. So we will move our high pointer to mid minus 1, and we will store the answer as mid. And if it returns false, that means the radius we have given to the predicate function is very small. We have to increase the radius, and hence we will move the low pointer here. Okay, so this is the simple binary search on answer code. Okay, now let's look into the predicate logic. The predicate logic, guys, is really simple. What we are doing, we have taken the radius r, n and m, vector a and vector v. We have initialized two pointer I and j. The pointer I is pointer to raccoons and the pointer j is pointer to the trash can. Okay, while j is less than m and I is less than n, what we are doing, our current trash can is b of j and our current raccoon is a of I. So we will take the absolute difference, the basically the Manhattan distance between them, and then we will check if the difference is less than equals to r. That means that trash can, it means the raccoon is in the range of that trash can. Hence check the next, not city, raccoon, right? So check the next raccoon now, and we will increase our pointer to check the next raccoon. The pointer will now point to the next raccoon. And here, if suppose the raccoon is not in the range of the trash can, then what we will do, we will check the next trash can, okay, we will check the next trash can. Hence we will move our j pointer. At the end, if all raccoons are covered, that means I is greater than equals to n, then we will return true, and else we will return false. This way we can determine if with the given radius r, we are able to feed all the raccoons, right? So the predicate logic was very simple. We will just use a two-pointer method, and the problem was based on binary search. The time complexity of the problem is, let's discuss the time complexity. The time complexity is nothing but big O of n log n. The log n is to binary search on answer, and the n is for two pointer or the predicate logic. So this is our time complexity. The space complexity is nothing. We have used no auxiliary space. We have only taken the vector input. So space complexity is big O of n. No extra space we have used. The key takeaway from this problem is the idea of binary search on answer, and the idea to get to know that the answer is a monotonic function, right? Whenever you see a monotonic function, you should always use binary search on answer. There might be other solutions to it, but this was the most optimal and best solution to this problem. All right, thank you. If you have any doubts, feel free to comment it in the comment section. I will try to answer them. Thank you.